I'm going to measure the current at a few places in my series circuit here. And of course, current is measured in amps. It's really just a count of how many electrons are passing through the wire or passing by any point in the circuit per unit time. So think of current as number of electrons flowing past you at some point in time. And I have an ammeter right here, which I will grab. And in order to measure current, you have to break the circuit. And so I shall split the circuit right here. I'll stick my ammeter in there. I don't know if I quite have enough room, but maybe I can. Oh, there we go, make it fit. So you can see that this particular circuit has 4 amps. And actually, I'll stick an ammeter some other place too, and we can see what we have. Maybe I'll stick an ammeter up here. And let me split this. I'll stick an ammeter up here, and I don't know if you're going to be surprised or not to find out that there's also 4 amps of current flowing through the circuit at this point. Again, current is how many electrons are flowing past some point per unit time. And so if at this point in the circuit there are 4 amps of current, that's how many electrons are flowing past me. Well, there's no branches for the current to flow other than this one little loop, so there must in fact also be 4 amps flowing through the circuit at this particular point. As a matter of fact, in a series circuit, there's only one path for electrons to flow. There must be the same current at every point in the circuit. It's not always going to be 4, just to be clear, but it doesn't matter where I measure the current, it will be the same at every single place. And finally, let's take a look at current in a parallel circuit. So I've already built this whole circuit for you, and you can see that I'm measuring current at a bunch of different places. Here, so I imagine electrons, of course, are flowing out of my battery. Here I'm measuring the current at 2.1 amps. Now notice some of the electrons are going to flow in this little direction, this loop, they're sometimes referred to it as, and some of the electrons are flowing up this loop. Well, you might notice that this is different than a series circuit. If there's more than one path for electrons to flow, some will go this way, some will go that way. And if I look at these amps, 0.6 amps, 1.5 amps, in fact, the sum of these is 2.1, which of course makes sense. Amps, of course, current is how many electrons are flowing. So if 2.1 amps worth of electrons are flowing this way and 0.6 are flowing up this way, the rest of them must be flowing this way. 1.5. So the sum of the currents flowing into one of these little nodes, one of these little intersections here, must be equal to the total amount flowing out. In other words, 0.6 plus 1.5 flowing into this point is equal to the amount flowing out, 2.1. So here again is 2.1 amps flowing through the battery, still 2.1. Some are going this way, 0.6. The rest must be going that way. And if I added another branch, the sum of all those branches would be equal to 2.1. Makes total sense.